In the present video, we solve the assignment problem by applying the Hungarian method. Let's see the problem. A department of a company has 5 employees with 5 jobs to be performed. The time that each man takes to perform each job is given in the effective matrix. How should the job is to be allocated? One per employee so as to minimize the total man hours. Here given the 5 jobs A, B, C, D, E and 5 employees 1, 2, 3, 4, 5 respectively. So number of rows and number of columns are equal to the 5. Then given assignment problem is balanced. Let's see the solution. First phase is row and column reductions. For this, first we subtract the minimum number of each row from the entries of that row. Next step is subtract the minimum value of each column from the entries of that column. First find the minimum value in each row. For the first row, minimum value is 5. Similarly, for the second row, minimum value is 3. For the third row, minimum value is 2. For the fourth row, minimum value is 7. And fifth row, minimum value is 4. Then subtract this minimum value from the each row. First we have to look for the first row. In the first row, minimum value is the 5. Then we subtract this minimum value 5 from the first row entries, that is 10 minus 5 equal to the 5 and 5 minus 5 0, 13 minus 5 8, 15 minus 5 10, 16 minus 5 11. Next we look for the second row. In the second row, minimum value is the 3. Then subtract this minimum value 3 from the second row entries, that is 3 minus 3 equal to 0, 9 minus 3 6, 18 minus 3 15, 13 minus 3 10, 6 minus 3 3. Next we look for the third row. In the third row, minimum value is the 2. Then subtract this minimum value 2 from the third row entries, that is 10 minus 2 8, 7 minus 2 5, 2 minus 2 0, 2 minus 2 0, 2 minus 2 0. Next we look for the fourth row. In the fourth row, minimum value is the 7. Then subtract this minimum value 7 from the fourth row entries, that is 7 minus 7 0, 11 minus 7 4, 9 minus 7 2, 7 minus 7 0, 12 minus 7 5. Next we have to go for the fifth row. In the fifth row, minimum value is the 4. Then subtract this minimum value 4 from the fifth row entries, that is 7 minus 4 3, 9 minus 4 5, 10 minus 4 6, 4 minus 4 0, 12 minus 4 8. Next we subtract the minimum value of each column from the entries of that column. Now find the minimum value in the each column. For the first column, minimum value is the 0. Similarly, in the second column, minimum value is 0. In the third column, minimum value is 0. In fourth column, minimum value is 0. Similarly, in the fifth column also, minimum value is the 0. Here, all columns are having the minimum value is 0. Then we subtract the 0 from all the entries of the column, we will get the same matrix. So this is the matrix after the row and column reductions. Second phase is optimization of the problem. And first step is draw a minimum number of lines to cover all the zeros of the matrix. For this, first you have to do the row scanning. In row scanning, start from the first row and observe if there is exactly one zero in that row, then mark a square around that zero and draw a vertical line passing through that zero. Otherwise, skip that row. In the first row, there is exactly one zero. Then mark a square around that zero and draw a vertical line. In the second row, there is exactly one zero. Then mark a square around that zero and draw a vertical line. In the third row, there is more than one zero. Then have to skip this row. And in the fourth row, there is exactly one zero. Then mark a square around that zero and draw a vertical line. In the fifth row, there is no zeros. Then you have to skip this row. After the scanning of the last row, check whether all the zeros are covered with lines. If yes, go to step 2. Otherwise, do the column scanning. Here, two zeros are not covered with the lines. Then we will go for the column scanning. In the column scanning, start from the first column and observe if there is exactly one zero in that column, then mark a square around that zero entry and draw a horizontal line passing through that zero. Otherwise, skip that column. Here, first and second columns already removed by the row scanning. Then you have to start with the third column. In the third column, there is exactly one zero. Then mark a square around that zero and draw a horizontal line. And in the fourth column, already we are removed by the row scanning. And in the fifth column, there is no zeros. Then you have to skip this fifth row. After the scanning of the last column, check whether all the zeros are covered with the lines. Here, all the zeros are covered with the lines. Then you have to move to the step 2. Step 2 is check whether the number of square marked is equal to the number of rows of the matrix. If yes, go to the step 5. Otherwise, go to the step 3. Here, square marked zeros are 4 and the number of rows are the 5. Then, square marked zeros are not equal to the number of rows. Then have to go for the step 3. Step 3 is identify the minimum value of the undeleted cell value. After identification of this minimum value of the undeleted cell value, then add the minimum undeleted cell value at the intersection points of the present matrix and subtract this minimum undeleted cell value at the undeleted cell values, and all other entries are remaining the same. Here, intersection points are the 8, 5 and the 0. And undeleted cell values are the 8, 15, 2, 6, 11, 3, 5, 8. Among these undeleted cell values, minimum value is the 2. Then we have to add this 2 for the intersection points for the 8, 5 and 0. Then these values will become the 8 plus 2, that is 10, and 5 plus 2, that is the 7, and the 0 plus 2 equal to the 2. Then we have to subtract the minimum undeleted cell value from the undeleted cell value. So remaining undeleted cell values we have to subtract the minimum value, that is the 2. Then 8 minus 2 will become the 6, and the 15 minus 2, it is the 13, 2 minus 2, 0, and the 6 minus 2, 4, 11 minus 2, that is the 9, 3 minus 2 equal to 1, 5 minus 2 equal to 3, 8 minus 2 equal to the 6, and remaining value should be the same only. This is the modified cost matrix, and we will go for the next step, that is step 4, go to the step 1. So once again we have to repeat the same steps. First we have to do the row reduction and column reduction. For the row reduction and column reduction, first we have to determine the row minimum value and column minimum value. Here minimum value from the each row is the 0. Similarly, minimum value in the each column is 0. So row minimum and column minimum values are 0. Then we subtract the 0 from the all the row and column entries. Then we will get the same matrix. Next we will go for the phase 2. So in the phase 2, first we have to draw a minimum number of lines to cover the all the zeros. For this, first we have to go for the row scanning. For the row scanning, first we have to start with the first row. In the first row, observe there is exactly 1 0. If row having the more than 1 0, then we have to skip. In the first row, there is exactly 1 0. Then mark a square around that 0 and draw a vertical line. In the second row, there is exactly 1 0. Then mark a square around that 0 and draw a vertical line. In the third row, so here having the more than 1 0, then have to skip the third row. Similarly, in the fourth row also having the more than 1 0, then I have to skip the fourth row. In the fifth row, there is exactly 1 0, then mark a square around that 0 and draw a vertical line. So after the row scanning, we will go for the column scanning. So in the column scanning, first column and the second column already we are removed. In the third column here having the more than 1 0, then we have to skip this row, and in fourth row already removed by the row scanning. Then we have to move to the fifth column. In the fifth column there is exactly 1 0. Then square a mark around that 0 and draw a horizontal line. After the scanning of last column, check whether all the zeros are covered with the lines. Here 1 0 is not covered with the lines. Then once again we have to go for the row scanning and the column scanning. So first I have to go for the row scanning. So first row there is no zeros. Similarly in the second row also there is no zeros. So third row already we are removed. So in the fourth row there is exactly 1 0. Then have to mark a square around that 0 and draw a vertical line. So in the fifth row also there is no zero, so I have to skip this fifth row. Then I have to move to the column scanning. So in the column scanning, first column, second column and third and fourth columns we are removed by the row scanning. In the fifth column also here there is no zeros, then we have to skip this fifth column. Then here once again I have to check. So So all the zeros are covered with the lines or not? Here all the zeros are covered with the lines. Then have to move to the next step, that is the step 5. Next, check the number of square marked zeros are equal to the number of rows. Here number of square marked zeros are 5 and number of rows are also 5. Then number of square marked zeros are equal to the number of rows. Then have to move to the step 5. So step 5 is the treat the solution as marked by a square. Then write down the initial time matrix and mark the square at the respected values, and this is the optimal time assignment. So optimal time assignment is, here we are assigning the jobs, job A for the employee 2, job B for the employee 1, job C for the employee 5, job D for the employee 3 and job E for the employee 4. And the time is job A and employee 2 is the 5 hours, so write down the 5. Similarly for the job B for the mechanic 1, so that is the 3 hours, and also for the job C with the employee 5 is the 2 hours, and job D with employee 3 is the 9 hours, and job E with employee 4 is the time is 4 hours. Then total optimal time assignment is the 5 plus 3 plus 2 plus 9 plus 4 equal to the 23 hours. This is the solution, and thank you.